Hello, welcome back. This is a video over Unit 6, Section 6, and we're going to be talking about operations with scientific notation. And so we did this a little bit in our last section, but I want to specifically talk about multiplying numbers in scientific notation and having exact answers. And the last one we had rounded answers and this is more precise, okay? So what I want to talk about is multiplying numbers in scientific notation. So let's first think of an example, okay? And I'm just going to make up random numbers. But what I'm going to do is I'm going to take 3.27 times 10 to the 6th power, okay? And I'm going to multiply this number by another number, which is going to be 5.89 times 10 to the 3rd, okay? And so when I'm multiplying two numbers within scientific notation, I want to multiply my numbers out front first, okay? And then I will multiply my secondary numbers second, okay? So let's multiply 3.27. So let's write this down. I'm going to do 3.27 times 5.89, okay? And I can put this in parentheses. Parentheses are your friend. And when I use parentheses to show that quantity, and if they're next to each other, that I'm multiplying those two quantities, okay? And then I'm multiplying this, so times, then let's do 10 to the 6th times 10 to the 3rd. All right. So when I simply just multiply 5.27 times 3.27 times 5.89, I'm going to get a value of 19.26. Okay. And then over here, when I do 10 to the 6th times 10 to the 3rd, and I'm going to write this out, this is just going to give me 10 to the 6 plus 3 power, okay? And so then what I have is I'll have 19.26 and then times 10 to the 9th, okay? And so when I have something like this, theoretically, you could leave it like this, all right? But if we're really putting our answer in scientific notation, remember, we need one decimal point out here. So remember, you should have one digit to the left of the decimal, okay? And so what I have here in this instance is that I have 19.26, okay? So in this instance, what I need to do is I need to move my decimal place to the left, okay? So I'm going to move decimal to the left 1 unit. Okay, and so what we have to do, if I move that decimal to the left 1 unit, then I need to add an exponent. Okay, so add 1. So if I move the decimal to the left 1 unit, then I need to add 1 to the exponent. Okay, and what that's going to look like is this. All right, if I move that to the left 1 unit, then my final answer is going to be 1.926 times 10 to the 10th power. Okay, and that's my final answer. Okay, so even though you do this, all right, and this part's pretty easy, just multiplying your numbers, multiplying your tens, all right, but then once you get this, if you don't have one decimal place to the left, all right, here I've got two digits to the left of the decimal, I have to move that decimal place to the left. And if I do that, then I have to add 1 to my decimal, okay, or to my exponent, okay? And that's the idea, all right? And we'll talk about if you have to move it to the other side. If you have to move the decimal place to the right, what do you do? So, all right, let's take a look at this next problem. All right, so in this problem, the speed at which light travels is approximately 1.86 times 10 to the fifth miles per second. It takes approximately 4.98 times 10 to the second seconds for light to travel from the sun to the earth. What is the distance in miles between sun and the earth? So this is kind of a weird problem. And in this, what I want to show you is I'm going to use the equation distance equals rate times time. So distance is equal to the rate times time. And this is just a standard linear equation. And so we're trying to find the distance. Okay, what is the distance in miles between the earth and the sun? This is my rate. Okay, so R is going to be equal to 1.86 times 10 to the fifth power. Okay, my time that it takes is going to be 4.98 times 10 to the second power. All right, and so if I'm trying to find the distance, then I just want to multiply these two numbers. All right, so I'm going to do 1.86 times 10 to the fifth times 4.98 times 10 to the second. All right, and so from here, all right, same thing I did up top. I want to multiply my numbers and then multiply my tens. All right, and so what we'll do is my distance is equal to 1.86 times 4.98. All right, so I'm going to multiply those two numbers together times, then I'm going to do 10 to the fifth times 10 squared. All right, and so once I've done this, all right, let me just do 1.86 times 4.98, and that's going to give me 9.26, which is kind of nice. Okay, so now with this, my distance is equal to 9.26, and then if I wanted to do the other one, I would do times 10 to the fifth plus 2 power. 10 to the 5 plus 2 power, which is going to be 10 to the 7th. Okay, so my distance then is going to be 9.26 times 10 to the 7th, and this is going to be miles. Okay, and that's a lot of miles. That's like 9 million miles or something like that. So, or 92 million miles, not exactly sure. But if I wanted to move my decimal place over 7 spots, I could actually figure that number out. Let's do that just because. All right, so 9.26 times 10 to the 7th. So let me write out 9.26, and let me come in here and do my decimal. So 1, 2, 3, 4, 5, 6, 7. I'm going to fill it in with zeros. Okay. And so, yeah, 92. So we've got 926, 1, 2, 3, 4, 5 zeros. And so put my decimals. This is 92.6 million miles. All right. So that's a pretty far distance. And so, it helps us to operate, within scientific notation, but you have to use your rules of exponents in order to do that. Okay. So let's take a look at the next one. Okay. In 1803, the United States added 8.28 times 10 to the fifth square miles through the Louisiana Purchase. Huge purchase. And a good purchase. The land was purchased for $18.12 per square mile. Approximately how much did the United States pay for this land? So if I wanted to figure out the amount that I paid, I would take the amount of square miles and multiply it by the cost per square miles, and we'll just go ahead and do that. All right, so, and I can put this number into scientific notation if I wanted to, but I don't necessarily need to. So let's do this. All right, so my cost for this is going to be 8.28 times 10 to the fifth power, and then I'm just going to multiply that number by 18.12. Okay, so again, when I'm multiplying numbers, I can reorder these and do whatever I want. So I'm going to take these two numbers here and multiply them together. All right, so my cost C is equal to let's do let me do this, 8.28 then times 18.12, and then we're going to multiply that by 10 to the 5th power, okay? So if I do 8.28 times 18.12, that's going to give me a total cost of, let me write this out, C is equal to then 150.03 and then times 10 to the 5th. Okay, and so remember, if I'm trying to put this into scientific notation, you know, my final answer is, and what I want to do here is move my decimal place 2 units to the left. Okay, so if I move 2 spaces left, move decimal, all right, 2 spaces left, then I have to look back up at my notes. Then I want to add the exponent. So that means I want to add 2 to our exponent. Okay? So if I move 2 spaces to the left, then I got C is equal to 1.5003 times 10 to the 7th power. Okay? And that's going to be my cost in dollars. Now, we can actually figure this out. And, you know, if I write out 1.5003, and I want to move this decimal 10 spaces to the left, to the right, 1, 2, 3, 4, 5, 6, 7. Okay. Let me just double check that. So it's 1, 2, 3, 4, 5, 6, 7. I'm going to put in 3 zeros here. All right, and that's going to give me my value. So I've got 15003,000. All right, so we paid $15 million for the Louisiana Purchase. Okay, so it's kind of a cool thing that you can do here by operating within scientific notation, but just want to make sure that we, you know, are able to move. Once we do the math, I think that part's easy. It's remembering where you move the decimal to the left. You add an exponent, okay? And so since I moved it 2 places here, I had to add 2 to my exponent, all right? So this is the important thing in your notes that you need to remember, okay? Everything else seems to be pretty easy. All right, next page. Okay, and so on this one, we want to divide numbers in scientific notation. So let's just write down an example. Okay, and this is going to be very, very similar to what we just did with adding decimals, or numbers with scientific notation, I mean. And so let's think of this. Let's do 6.4 times 10 to the, I guess, 8th power. And we're going to divide that number, so this whole number, divided by 8.2 times 10 to the 4th. Okay, so what I want to do is first write it out as a fraction. Okay, so you can write it out like this if you want, but let's write it out as 6.4 times 10 to the 8th divided by 8.2 times 10 to the 4th. Okay, and the first thing I want to do is I want to divide my numbers here. So I'm going to do 6.4 divided by 8.2, and that's going to give me 0.78. And I'm using a calculator to do that, to do a lot of this math. And then, but this part here, you know, if I wanted to divide these numbers, then I'm simply going to do, this is going to be times, and then I'm just going to divide those numbers. So this is going to be 10 to the 8 minus 4 power. So then I finally get the answer, 0.78, then times 10 to the positive 4th power. Okay, so now remember, I need 1 digit in front of, to the left of my decimal. Okay, so I need to move my decimal to the right 1 unit. All right, so if I move the decimal to the right, then I need to subtract an exponent. So move a decimal to the right, then I subtract an exponent. Okay? So what I'll end up getting here is I'll get 7.8 times 10 to the third power. Okay, and that's the idea. All right, so I'm simply just doing it with numbers, but we're gonna do it with some real world examples. Okay, so on this one, real world application. So on this problem, it says that light travels at a speed of approximately 1.86 times 10 to the fifth miles per second. Okay, so every second it travels this many miles, which is really fast. A car traveling 70 miles an hour travels at 1.94 times 10 to the negative 2 miles per second. Okay, so every second, like if you're going 70 miles an hour, you're not going like a full mile. Okay, when you're going 70 miles per hour, you're going about a mile per minute. So when you're talking about in terms of seconds, you're not going that fast. Okay, so how many times faster does light travel than a car? Okay, when it's asking this, how many times faster does light travel than a car, it wants to know by what factor does light travel faster than a car. So factor means multiply. So I would need to take this number here, multiply it by a number to get this, okay? But in order to multiply, we have to do division, okay? So what I'm going to do is simply just divide these numbers, and we're going to do 1.86 times 10 to the fifth divided by 1.94 times 10 to the negative 2. Okay, so when I divide these numbers, I'm going to divide 1.86 by 1.86 divided by 1.94, and that's going to give me a value of 0.96. Okay, then on the next one, what I want to do is I'm going to multiply that, and I'm going to, if I'm dividing my tens with exponents, I've got to then subtract my exponents. So I'm going to have 10 to the 5 minus negative 2 power. So this is going to end up giving me 0.96, then times 10 to the 5 plus 2 power, okay, which is then going to give me 0.96 times 10 to the 7th power, okay? And what I want to do is I then want to move my decimal to the right, okay? So if I move my decimal place to the right 1 unit, and I got to look back up here, okay, then I'm going to subtract an exponent, okay? So this is going to give me a value of 9.6 times 10 to the 6th power, okay? So I move right, move my decimal place to the right, and so I subtract an exponent, okay? 1 from my exponent, all right? So however many times you move that decimal place is what you have to move over. All right, let's do this, dividing with a decimal. What is the quotient of 6.72 and 3.2 times 10 to the third? So when I'm doing this, I just want to write it out. And if you're putting this in, I should have done this on the other one, but if I'm just taking a number, 6.72, and dividing it by a number in scientific notation, then I got to multiply this number by 1, okay? And so that's how the 10 to the 0 comes in, is that 10 to the 0, remember, is just 1, okay? So I'm not changing the value of this number here, but I'm simply just putting it in so I have values to work with. All right, so then what I'm going to do is I'm going to do 6.72 divided by 3.2, 0.72 divided by 3.2, and that's going to give me 2.10. All right, so that's going to give me 2.1, and then times, if I divide these numbers, then really what I've got is I've got 10 to the 0 minus 3 power. All right, so then as I do this, I'm going to have 2.1 times 10 to the negative 3 power, and that is my answer, okay? So just doing that. And I don't have to move my decimal place because I already have a 1 digit to the left of my decimal. All right. You can use this stuff on a calculator, but if you do encounter stuff on a calculator, then let me know and I can go over and talk to you about it. But Otherwise, just do it by hand and use a calculator to do the individual parts, and then keep your stuff in scientific notation. Okay. So I hope you enjoyed this video. I'll talk to you soon. See you later. Bye.